The first topic that I learned in this week's videos is Newton's second law. It is the most fundamental theorem of mechanical physics. It describes how force can affect an object's motion, so the net force of the system is directly proportional to the object's acceleration. The more force that you apply on an object, the faster it goes. Um, I learned Newton's second law many times during my high school because it is such a fundamental thing for physics. However, the form that I use the most is F net equals ma. In the lecture, I was introduced a new way to express Newton's second law. Vf equals Vi plus F net over m times delta t. I think this is a better form for labs because it is hard to measure acceleration directly with the tools that we have in hand. Using this equation, we can simply measure the distance and time, and we can easily find the initial and final velocity using distance and time. I think this equation also provides a clear way for us to see how force can impact an object's velocities because the final velocity is proportional to the force that is applied. Um, I also understand how does it work when an object is moving at a constant velocity. The net force must be zero because in the equation F net equals m times a, when an object is moving in a constant velocity, it doesn't have any acceleration. So using Newton's second law, the F net must equal zero to make this law work. The second thing that I learned is how to use Tracker and Python during labs. In high school, I performed one lab using Tracker, and so we found the soccer ball's velocities using Tracker to analyze its position and time. Though Tracker was not new for me, but I was rusty on how to use it. The videos explained to me well on how to use it from scratch, how to add and find a coordinate system, how to add the length scale, and how to create a graph after all the data is being calculated. This would certainly be useful for me for my labs in the next week. And on the other hand, I have no idea how to use the computer simulators. I saw that from the Glow Script software and the video that we need to use computer coding and Python and to like simulate the lab that we're doing. And I never learned Python, and this will be a big challenge for me throughout the labs. Luckily, I learned a little bit of coding during the lecture videos. For example, I understood how to write a comment and how to find the position and time of the object using Newton's second law. I also learned how to create a good video clips and a lab report. Like I need to shoot my experiment in a place that has really good light because if it's being shooted in a poor lighting condition, like the computer can like see the object, and the frame rate can be changing as I'm shooting. And I also knew that my video report needs to be clear and neat because like if they're like messed up and all over the places, it would be hard for my peer and my teachers to understand what am I doing for the lab. The third topic that I learned is the spring force and the Hooke's law. I also learned this in high school. The restoring force that the spring exerts on the object is a product of the spring constant and the displacement that the spring is compressed. I found myself interested in the spring constant because this relates to my major in material science. how can the materials of the spring affect its properties, which ultimately results in the change of the restoring force. During this week's video, the most confusing part was using the vectors to represent forces and velocities. It will still be a little bit hard for me to do physics using vectors, especially during the assignments. I found myself experiencing difficulties when trying to find the directions of the displacement vectors from the velocity vectors. I tried to watch some YouTube videos and they were helpful because they use practice problems to help me understand. I will also try to use CampusWire for help when I'm experiencing difficulties for coding later on. Overall, the videos and the presentation are clear and easy to follow.